Hello and welcome to the Maths Matrix. My name's Rebecca and in today's video we're going to be doing rounding to a given number of decimal places or significant figures. All you'll be needing for today's lesson is a pen and paper. Rounding to a specific number of decimal places or significant figures isn't something that's going to be tested in its own right on a higher tier GCSE, but it's something that if you can't do, you might throughout the paper lose a mark here and there, because quite often as part of a bigger question they'll say giving your answer to 1DP or giving your answer to 3SF. And if you don't know how to do that and you give your answer to the wrong degree of accuracy, they will take a full mark off you. Also, those questions that you sometimes get on non-calculator papers where they give you what looks like an impossible calculation to do without a calculator, but they say estimate the answer to this. That relies on being able to round each of the given values to one significant figure. And so if you don't know how to use decimal places and significant figures, there are quite a few places across an exam series where you might drop marks. So it's an important basic skill to sort out. Rather than working on the big board today, I've got a really little whiteboard and we're going to try working on that today. I'm hoping that there won't be any glare off it and that I'll be able to, dependent on what subject I'm doing, switch between the big board and the little board, dependent on what's best for that lesson. So we'll try the little board today and we'll see how that works out. Right, so I'm all set up on my whiteboard, and first of all we'll talk about decimal places. If we consider the number 23.61837, that number has 5 decimal places in it because there are 5 distinct digits after the decimal point. So when we're dealing with decimal places, what comes before the decimal point doesn't really matter. We only start counting after the decimal point. So that is our first decimal place, that's our second decimal place, that's our third decimal place, and so on. If we wanted to round this number to 1 decimal place, what we would do is we would make a sort of cut. You can do it physically if you want to, but in time you'll be able to do it in your head. So we make a cut after the first decimal place and we look at what's happening on the second decimal place. Now, the number at the second decimal place is 1, which is less than 5. And because the number after that dotted line is less than 5, we round this number down to 23.6. So we leave it at 23.6. Now, if instead of rounding it to 1 decimal place, I wanted to round the same number to 2 decimal places, then this time I would make a cut after 2 decimal places, so between 2 and 3. And I would look at what's happening on that side of the dotted line. So if I wanted to round this number to 2 decimal places, after the dotted line, I've got 8, which is bigger than 5. And because 8 is bigger than 5, that means that I change that number 1 to number 2 and round this number to 23.62. Still working with this number. If we were rounding to 3 decimal places, then we'd make a cut after the third decimal place. So the first decimal place, the second, the third, and we'd make a cut. And we'd look at what's happened on the right of that cut. And to the right of the cut, we've got a 3, which is less than 5, which means we just leave that as it is. So that would be 23.618 to 3 decimal places. So if you round 19.7914, if you round that to 1 decimal place and to 2 decimal places. So you're going to have 2 separate answers, one for when you've rounded it to 1 decimal place and another for when you've rounded it to 2 decimal places. And then if you round 0.0716 if you round that to 3 decimal places. Okay, so just like before, if you hit pause, have a go at those, and then when you've done them, hit play and I'll go through them. Right, so if we first of all round this to 1 decimal place, if I make a cut there after the first decimal place and look at what happens to the right of the dotted line, that's 9, which is bigger than 5, which means the 7 is going to get kicked up to an 8. So that's going to be 19.8 to 1 decimal place. Looking at it to 2 decimal places, if I make a cut after the second decimal place and look at what happens to the right of the line, this time it's 1 to the right of the line, which is less than 5, and so that would be 19.79 to 2 decimal places, so nothing would change. Looking at the bottom one, if I want that to 3 decimal places, that's my first decimal place, that's my second decimal place, and that's my third decimal place. So I make a cut there. So the 0 does count as your first decimal place, you do include it. So we've got 1, 2, 3 decimal places and a cut. After the cut, the number is 6, which is bigger than 5. So I move the 1 to a 2. So the 1 gets kicked up 1 place and becomes 2. So to 3 decimal places, that number is that. If we now consider that number, 12.9735, if we wanted to round this to 1 decimal place, we would make a cut there after the 9, and we would look at the number to the right of the cut. This is if I was rounding to 1 decimal place. To the right of the cut, the number is bigger than 5, so we would move the 9 up 1 place. We would increase 9 by 1. But the problem there is that we get 10, and you can't change 9 into a 10 after a decimal point. So if we increase the 9 by 1, what then happens is it makes the 12 turn into a 13. What we're actually doing is we're adding on 0.1, which makes that become not 10, but it makes it go back to 0. So if you imagine watching, when you get like a timer or a stopwatch, it would go 1.1, 1.2, 1.3, and so on. And then after it gets to 1.9, it would go not to 1.10, but it would go to 2.0. That's what's happening here. So when we kick that 9 up 1, what actually happens is it moves on to a whole new number. So it moves to 13.0. So to 1 decimal place, 12.9735 is actually 13.0. So if we look at another one like that, if we think about 5.99386. If we wanted that to 2 decimal places, then we would make a cut after the second decimal place. To the right of the dotted line, we've got a number that's less than 5. So the 5.99 would stay as it is if we were rounding to 2 decimal places. However, if we were rounding to 1 decimal place, let's get rid of that, trying not to smudge out my original number. If we wanted, instead of rounding to 2 decimal places, to round that just to 1 decimal place, then we would make a cut after 1 decimal place. And to the right of the cut, we've got a 9, which is bigger than 5, which would mean that that 9 would get moved up by 1. But we can't move from a 9 to a 10. We have to go up to 6.0. So to 1 decimal place, 5.99386 is actually 6.0. So they can be a little bit tricky when they've got 9s involved. So I'll give you a couple more to try. If you do 21.9716, if you round that to 2 decimal places first of all, and then round it to 1 decimal place after that. And if you do 0.97338, if you round that to 3 decimal places and 1 decimal place. So like before, hit pause, have a go at those. When you've done them, hit play, and then I'll give you the answers. Right, so looking at that first one, if I make a cut there after 2 decimal places, that's less than 5. So the 7 stays as it is. So to 2 decimal places, we have 21.97. So nothing really changes. If, however, I wanted it to 1 decimal place, I would make a cut there. And to the right of the line, we now have a number that's bigger than 5. So because we have a number that's bigger than 5, the 9 gets kicked up 1 place, but we can't put 10. We have to go from 21.9 to 22.0. So that number to 1 decimal place is 22.0. Get rid of those. So the next one, if I wanted this number to 3 decimal places, I'd make my cut after the 1st, 2nd, 3rd decimal place. And to the right of the line, I've got a number that's less than 5, so everything would stay as it is. So 0.097 is the answer to 3 decimal places. However, if I wanted it to 1 decimal place, then I would make a cut there after the first digit after the decimal point. To the right of the line, I've got a number that's bigger than 5, which means that the 0 changes into a 1. The 0 gets moved up by 1. So to 1 decimal place, the answer is 0.1. All right. And that's rounding to particular numbers of decimal places. Now let's talk about significant figures, which are the ones that people tend to like less. So people tend to be not too bad at decimal places for the most part, but they often don't like significant figures, even though they work actually quite similarly. If we consider the number 0.0041632, that number has 1, 2, 3, 4, 5, 6, 7 decimal places. But if I wanted to round this number to 2 significant figures, which we can abbreviate as SF, I don't start counting from there. So if I wanted to round this number to 2 decimal places, that's my first decimal place and that's my second decimal place. But that's not my first significant figure. This is my first significant figure. So you start counting significant figures from the first number that isn't 0. So this is my first significant figure. That's my second significant figure. That's my third, that's my fourth, and so on. And after that, it does work just like decimal places. It's just that the place that you start from is different, because in decimal places, you start straight after the decimal point. But in significant figures, you start with the first non-zero number after the decimal point. So we ignore that, and that's our first significant figure. So if I wanted to round this to 2 significant figures, that's my first significant figure, that's my second significant figure. I make a cut. To the right of the cut, I've got a number that's bigger than 5, and so the 1 gets kicked up to a 2. So the answer would be 0.0042 to 2 significant figures. Now let's think about the number 0.68052. 9. This number has 6 decimal places, and we do count zeros as significant figures as long as they're coming after a proper number. So if I had 0.06800519, that would not count as a significant figure because it comes before any proper numbers, before any non-zero numbers. But this one does count as a significant figure because the 6 counts as our first, the 8 counts as our second, and we do include the 0 as a third significant figure. So as long as your number doesn't start with 0, you do class any other zeros as significant figures. So if I wanted to round this to 3 significant figures, that's my first significant figure, that's my second, that's my third significant figure, even though it's a 0, because we've already started counting significant figures by then. So I'd make a cut. To the right of the line, I've got 5. If you have 5 or more, you have to kick that number up 1 place. So to 3 significant figures, I have 0.681. So if you have a go at 0.7139228, if you round that one to 2 significant figures and also to 3 significant figures, and then if you do 0.0087173, if you round that to 2 significant figures and 1 significant figure. So as before, press pause, have a go at those, and then when you've done them, hit play and I'll give you the answers. Okay, so looking at the top one, that's my first significant figure, that's my second significant figure, so I make a cut there. The number to the right of the cut is less than 5, so nothing changes. So the first one is 0.71 to 2 significant figures. If I wanted it to 3 significant figures, that's my first significant figure, that's my second, that's my third, so I'd make a cut there after the third one. And because 9 is bigger than 5, that means I do have to kick the 3 up 1 to become a 4, so that the answer is 0.714 to 3 significant figures. Looking at the next one, that is my first significant figure. So all of these zeros get ignored, and that's my first significant figure. That's my second significant figure. So if I was rounding to two significant figures, I'd make a cut there after the second significant figure. Because to the right of the line I've got 7, which is bigger than 5, that means the 1 gets kicked up one place and becomes a 2. So I get 0.00082 to two significant figures. If I was rounding the same number to one significant figure, that's my first significant figure. So I'll make a cut after it. Looking to the right of the cut, I've got 1, which is less than 5, so nothing changes. So to one significant figure, I have 0.0008. Now let's think about the number 263.8206. Now here, if we were to round this number to a certain number of decimal places, we only look at what's going on after the decimal point. So that's our first decimal place, that's our second decimal place, that's our third decimal place, and so on. If we're looking at significant figures, we actually look at what goes on before the decimal point as well. So that is my first significant figure. That's my second significant figure. That's my third significant figure, and so on. So with decimal places, you only start counting decimal places after the decimal point. But with significant figures, you start counting from the first number that isn't 0, no matter which side of the decimal point it's on. So in this case, that's my first significant figure. So what I'm going to do now is I'm going to round this number to 4 significant figures. I'm going to round it to 2 significant figures, and I'm going to round it to 1 significant figure. So if I want to round this number to 4 significant figures, that's my first sig fig, that's my second, that's my third, that's my fourth. So I make a cut after the 4th significant figure, which in this case is also the first decimal place, but that won't always be the case. So cutting after my 4th significant figure, the number to the right of the dotted line is 2, which is less than 5. So everything on the left of the line stays the same. So to 4 significant figures, if instead I wanted to round to 2 significant figures, then I would make my cut after 2 significant figures. So I'd make my cut there. And again, looking at the right hand side of the line, I have a number that's less than 5, which means that the 2 stays as a 2 and the 6 stays as a 6. Now what's slightly different in this case is that I don't just leave it as 26, because this number here is 260 something and this number is 26, and the two are very different in magnitude. Something in the hundreds is much bigger than something in the 20s. So where there was a 3, I now fill in a 0. So what I'm saying is that to 2 significant figures, the number 263.8206 is 260. So if we look at the next one, where we're rounding that same number to 1 significant figure, if I make a cut there after my first significant figure, to the right of the line, I've got a number which is bigger than 5, which means that 2 gets kicked up to a 3. But I need to be working in the hundreds because the original number is in the hundreds. It's 263 point odd. So I now fill in a 0 where there was a 6 before, and I fill in a 0 where there was a 3 before as well. So I think people can find that a bit confusing because that's the bit that is very different to decimal places, because with decimal places you only consider what happens after the decimal point. With significant figures that start 0 point, you only look at what happens after the decimal point. But if the number is something like in the thousands or in the hundreds or something like 50 odd, you have to consider what happens before the decimal point as well, and you have to make sure that the answer that you get is of the same kind of size as what you started with. So let's look at a couple more like that. If I have the number, let's have 91,782.631. That number has 1, 2, 3 decimal places, but it has 1, 2, 3, 4, 5, 6, 7, 8 significant figures. If I want to round this number to, let's have it to 5 significant figures, let's have it to 3 significant figures, 2 significant figures, and 1 significant figure. Oh, you can't see those. So if I wanted to round that to 5 significant figures, I'd count 1, 2, 3, 4, 5 and make a cut there between the 5th and the 6th significant figure, which is also in this case on the decimal point. To the right of the dotted line, I've got 6, which is bigger than 5, which means that the 2 gets kicked up to a 3 and everything else stays the same. So I'm saying that to 5 significant figures, this number would be 91,783. If I didn't want so much accuracy, if instead I only wanted to work to 3 significant figures, then I would make my cut at 1, 2, 3 significant figures, and I would look at what's happening to the right of the dotted line. To the right of the dotted line, I've got 8, which is bigger than 5, which means the 7 gets kicked up to 8, and the 1 and the 9 will stay the same. But this time, those 3 digits there say 918 at the moment. This number says 91,000 and odd. So what I have to do to keep this number of the same order of size as the number above it is I've got to fill in those zeros, so that now I do have 91,000 and odd in my answer, as well as in the number that was originally given. If we look at the next one, so the next one said we wanted it to 2 significant figures. So if I was going to round that to 2 significant figures, I'd make a cut there. So that's my first significant figure, that's my second significant figure. To the right of the dotted line, I've got 7, which is bigger than 5, which means the 1 gets kicked up to a 2. The 9 stays as a 9. And then again, I've got a difference then in the size of these numbers, because 92 is nowhere near the same size as 91,000 and odd. So I have to fill in a 0 and a 0 and a 0 where the 7, 8 and 2 were, to make that 92,000, which is much more similar in size to 91,000 and odd. If I just wanted it to 1 significant figure, I feel like I keep saying that wrong, it's quite hard to say repeatedly, significant figure. If I only wanted it to 1 significant figure, I would make my cut there, after the first one. To the right of the line, I've got 1, which is smaller than 5, which means that the 9 doesn't get moved up, it just stays as a 9. But 9 is a very different size number to 90,000 and odd, so what I would then do is fill in zeros in that position, that position, that position, and that position. Then I've arrived at the decimal point, so I can stop there. So to 1 significant figure, that number is 90,000. So if you do 2,351.3 682. If you round that to 3 sig fig and to 2 sig fig, and then if you do 107,363, if you do that to 4 sig fig and to 2 sig fig. So as before, hit pause. When you've done them, hit play, and I'll go through them. Okay, so looking at the first one, if I make a cut after the third significant figure, the number to the right of the line is 1, which means nothing to the left changes, which means I have 2, 3 and 5. But 235 is a different size number to 2,350 odd. So where there was a 1, I now fill in a 0. If I only wanted it to 2 significant figures, then I'd make the cut there between the second and third. Because that number is 5, it means that the 3 gets moved up to 4, the 2 stays as 2, but 24 is much smaller than 2,000 and odd, so I fill in a 0 where the 5 was and a 0 where the 1 was. So to 2 significant figures, that number is 2,400. Finally, if we have 107,363 and we want to round that to 4 significant figures, 1, 2, 3, 4, and make a cut. To the right of the line I've got 6, which is bigger than 5, so the 3 gets changed to a 4 and everything else to the left stays the same. But that number is much smaller than that number, so I have to fill in a 0 where the 6 was and a 0 where the 3 was. If we wanted that number to 2 significant figures, then we would make a cut after 2 significant figures. To the right, of the dotted line, I've got 7, which is bigger than 5, which means that on the left of the line, that 0 has to get moved up 1 place to a 1. That 1 will stay as a 1. 11 is way smaller than 100,000, so I now have to fill in zeros where the 7, 3, 6 and 3 were. So that to 2 significant figures, 107,363 gets rounded up to 110,000. All right. So I think sig fig can be a little bit confusing when you first start them, but as I said, on a higher paper you don't actually get asked a lot about them in their own right. It's mainly for things like the sine and cosine rules, trigonometry, perhaps Pythagoras' theorem and things where you might be asked to give your answers to a certain number of decimal places or significant figures. The takeaway points really are that for decimal places, you only look at what happens after the decimal point. So your decimal places begin after the decimal point and you make your cut, and if it's 5 or more, you round up, and if it's less than 5 where your cut is, you leave it the same. For significant figures, you start counting after the first non-zero digit, regardless of which side of the decimal point that happens on. I hope that helped. Don't dwell on it for too long, because like I say, it's just a little thing really, but it does stand to cost you a few marks if you can't do it, but you won't be examined on it in its own right, so don't stress about it too much if you can't do it. All right, thank you for listening to that one, and I will see you in the next one.